Okay, in question 2 of tutorial 7, we're going to derive aggregate demand from our aggregate expenditure model. Okay, so this is a model with numbers that we should all be familiar with. Wealth is 8 trillion. Future expected income is 12 trillion. The price level is 14.5. The real rate of interest is 3.5%. The marginal propensity to consume is 0.75. Tax revenues is 3 trillion. Business investment expenditures is 2.75 trillion. Government spending is 3 trillion. And net exports are a negative 0.5 trillion dollars. So let's ask the question, what happens if the price level rises by $1,000? So it goes from 14.5 to 15.5. Now notice, when it was 14.5, less is being subtracted from the intercept. When we increase it by $1,000, more is being subtracted from the intercept, which is why the new aggregate expenditure model's intercept is 4 instead of what it was, 5. So the new model is down here. It shifted downward, right? The MPC didn't change. So this is a parallel shift in the aggregate expenditure model. Now, we want to find the new GDP level, because what's going to end up happening is at the moment the price level rises, we're going to hold GDP constant, and the aggregate expenditure model will shift down to here. At this point here, real GDP is 20, but aggregate planned expenditure is less than 20. So what's going on here? People are planning to spend less than they were a week ago or a month ago. So you're going to IHOP less often. When people go to IHOP less often, holding everything else constant, the stock of flour in the back room rises because fewer pancakes are being made. Same thing with eggs. Eggs are stacking up because they're being replenished at a certain rate, but they're being depleted at a smaller rate because of less foot traffic. So you'll see your inventories rising. When you see your inventories rising, the owner of the business will call the suppliers and say, hey, lower my replenishment rate of my inventory. I don't need 100 pounds of flour each day. I only need 50, right? So when all businesses do that, we end up at this point down here. And so in order to calculate this point down here, we have to impose the equilibrium condition, where aggregate planned expenditure equals real GDP. So all we're going to do, in order to impose that condition, we're going to replace that with Y, like we did here. And we solve for Y, and we get 16. So we get $16 trillion. Now, if I plug 16 into here, I'm going to get 16, right? I'm going to get 16. Okay, so what happened here? The price level rose by 1,000. GDP fell. The amount of money people are spending on final goods and services fell from 20 trillion to 16 trillion. That's the law of demand in a macro sense. So at this dot here, where the price level is 14.5, GDP was 20. Right? At this point, the price level is 15.5 and GDP is 16. And then we connect the dots and we get the aggregate demand model. Okay? So the aggregate demand model comes from aggregate expenditure, where we hold everything but the price level constant. Higher prices, less real GDP demanded. Okay, let's do our question in the tutorial now. These are the same exact numbers that we had before. So we plug in the $8 trillion for wealth, 12 trillion for future expected income, 3.5 for the real rate of interest, 0.75 for the MPC, 3 for taxes, net of transfers, 2.75 for business investment, 3 trillion for government spending, and net exports are a negative 0.5. Now, I waited until the end to throw in the price level, and I made it black. The other ones are green, right? Because we're going to end up changing this number in this problem. And then I threw in the MPC there at 0.75. So all this adds up. All this arithmetic gives us 5, which should be familiar. We've done that 3 or 4 times now and got that same number with the same exact setup of the problem. Now the MPC equals 0.25. I mean, the marginal propensity to save equals 0.25 because the marginal propensity to consume is 0.75. It and the MPC imply that for every dollar of disposable income received, consumers' consumption goes up by 75 cents and savings goes up by 25 cents. Okay, now we're going to graph this model. It's this solid black line. And notice I put in parentheses with the price level equal to 14.5. See that? To graph the line, we have to make real GDP 0, right? And when we plug in 0, we get 5, right? So the height of the aggregate expenditure model when GDP is 0 is 5. And then I need to plot this point. Oh, sorry, I already give you that real GDP is 20 in equilibrium. So I give you that, right? And then we plug the 20 into that expenditure model, and we get 20, right? Because 0.75 times 20 is 15. 15 plus 5 is 20, right? Then we label that point, after we plug in the number down here, 20, we label that point E1. Okay, so this is a review of what we've already done. The only thing I've added is this parentheses here where the price level is 14.5. Okay, now in this situation, just like we did before, the price level decreases by this should be increases to $15.5 trillion. It was 14.5, now it's 15.5, so it should be increases. This gives us an aggregate expenditure model of 4 right here, just like we did in the notes, right? So the aggregate expenditure model is at 4. The original model was at 5. The new model is at 4 in terms of the intercept, right? And then I labeled this line, aggregate expenditure, in parentheses, with the price level being 15.5. Okay? So the initial price level was 14.5. The new price level is 15.5. The change in the price level, this is what it is, and this is what it was. The change in the price level is 1. Okay? Which was given to you, right? Now I want to find this equilibrium here, right? So I got to impose the equilibrium condition. I got to change this to Y, because on the 45-degree line, aggregate expenditure equals real GDP. So I replace AE with Y, and I solve for Y, and I get 16. Again, this should look familiar. We just did it. I plug 16 in the aggregate expenditure model, and I get 16. Because 0.75 times 16 is 12, and 12 plus 4 is 16. Okay. So the Y0, the initial GDP level is 20. The new GDP level is 16, right? Again, the change in the price level is 1. This is what it is, and this is what it was. So 15.5 minus 14.5 is 1. Now down here, real GDP is 16. It was 20, so the change in GDP is a negative 4. Okay? So this right here is going to give me the slope of the aggregate demand model, right? Because remember, the slope is the rise, in this case the change in the price level, over the run, which is the change in GDP, minus 4. Okay, so the slope of aggregate demand is the rise over the run, the change in the price level over the change in GDP, minus 0.25. The slope of aggregate demand equals the negative MPS, marginal propensity to save. That's not by coincidence. That's by model, not coincidence. Okay, so in our model, where we assume The MPC is 0.75. The slope of aggregate expenditure, which is the MPC, if I subtract 1 from that, I'm going to get the slope of aggregate demand of 0.25. And that's not by coincidence. And you'll know why in a second. Okay, so now we're going to use the point slope equation from algebra, right? Y minus y1 equals m, the slope, times x minus x1, the point slope equation. The blue is a point, the green is a slope. So that's why we call it point slope. We're going to use the point slope equation. Okay? And one of our points was when the price level is 15.5, GDP fell to 16. And we know our slope was negative 0.25. So if I multiply, okay, there's our aggregate equation. Okay, so what do I do here? I'm distributing the negative 0.25 to the y right here, right? And then I'm distributing the negative 0.25 to the negative 16. What is a negative 0.25 times a negative 16? Well, it's 4, correct? Right? Negative 0.25 times y is negative 0.25 times y. Negative 0.25 times 16, negative 16 is a positive 4. So now I'm just adding 15.5 to both sides. And I get a price level intercept of 19.5, which is right there. And a slope of negative 0.25. So I'm just solving the point slope for this price level. Okay. Now I can verify the above equation is indeed the aggregate demand equation by substituting the initial level of GDP in there, right? Remember what the initial level of GDP was. It was 20. What was the price level then? Remember it was 14.5? So if I plug 20 into here, right, I should get 14.5, and sure enough, I get 14.5. Now, when the price level increased to 15.5, GDP fell to 16. So if I plug 16 into here, I get a price level of 15.5. So that's our aggregate demand model. Okay. Now, the aggregate demand model can also be found using this equation. It looks a lot like the aggregate expenditure model. Only the MPS, the negative MPS is the slope. And notice there's no price level in here. Essentially what we did is we took the negative price level here and we added it to both sides. And then we subtracted real GDP from both sides. So this is our general form equation for aggregate demand. And aggregate demand is a function of overall wealth, the expectations of future income, the real rate of interest, the marginal propensity to consume, taxes, investment expenditures, government spending, and net exports. Our wealth was 8. Expected future income was 12. The real rate of interest was 3.5. The marginal propensity to consume was 0.75. Taxes were $3 trillion. Investment was $2.75 trillion. Government spending was $3 trillion. And net exports was a negative 0.5. And that gives us an intercept of 19.5, which is exactly what we had before. And the slope is a negative 0.25. Okay, so this model here is graphed down here where we hold all these things constant at those current values. Okay, so this derives how we got that equation. So you might ask how we got this equation up here. You won't have to do this on any test. This is just for your own benefit. How did we derive this? I'll show you right here. Okay. Aggregate expenditure, right? This should look familiar. In equilibrium, AE equals Y, right? Now we're going to, like I said, we're going to add price level to both sides, right? And we're going to subtract Y over here. See that? Y minus Y is 0. So I have it over here, MPC Y minus Y. I've added the price level to both sides, which is why there's a price level here. Notice there's no price level in here, right? Then I'm going to factor out the Y here. I'm going to factor out the Y. See that? I just factored the Y here. If I pull a Y out of here, I'm left with MPC. If I pull a Y out of here, I'm left with 1. Now, what is 1 minus the MPC? That's the MPS. Now, before I do that, what do? I'm going to pull out a negative. If I pull a negative out of here, that makes that positive 1, and it makes this negative MPC, and it'll make this negative. See that? And then this right here is just the MPS. Okay, so that's how I got that equation. Okay? And this is just that same exact question where we substitute in the individual numbers and we get the aggregate demand curve of 19.5 minus 0.25y. Then we're just graphing it. And we get aggregate demand. We plug in the 16 trillion for the new level of GDP. That gives us a price level of 15.5. Okay, and that's the end of turning aggregate expenditure into aggregate demand.